Good morning and welcome to this late-breaking session titled The Potential of Using Artificial Intelligence to Solve the Puzzle of Salutogenesis. I am Dr. Emmeline Edwards, Director of the Extramural Research Division at the National Center for Complementary and Integrative Health. First, I would really like to thank the program committee for allowing us to include this session into the program. Our goal is for you to learn about NCCIH perspective on potential processes that are involved in salutogenesis and how new technology in artificial intelligence and machine learning would be strategies to help us fill some of our research gap. Yesterday, you heard the keynote from Dr. Rakel that emphasized that understanding salutogenesis requires a network approach. Today, Dr. Langevin, Director of NCCIH, will expand on that concept and will talk about the grand challenge of salutogenesis and how we are going to tackle this grand challenge at the NIH. She will be followed by Dr. Mudd, Program Director in the Clinical Research Branch, that will introduce the CIH community to the NIH Bridge to AI project and discuss ways for all of you to get involved into this exciting project. So as at the end of this session, Dr. Jeff Dusek will actually moderate the question and answer session. Helene, I turn it over to you for your presentation.
Well, thank you so much, Emmeline. And it is really a pleasure to be here. Really, Dr. David Rakel's great talk yesterday set us up perfectly, and we're very grateful for this opportunity to discuss the potential for using artificial intelligence to better understand salutogenesis. I'll share my screen now. Hopefully you can see this. So as Dr. Rakel mentioned, the term salutogenesis was coined in the 1970s to describe the ability to remain healthy despite being exposed to stressors. And the term has been used in various ways since, mostly in the psychology literature. But in this presentation, we will be using the term according to its basic etymology, which comes from the Latin salus, which means health, and the Greek genesis, meaning creation, literally the creation of health. And to understand this basic concept, I find it useful to consider these three plants. The one on the left looks pretty healthy, and the one on the right looks like it's got some kind of disease. But what about the one in the middle? It looks like if it got somewhat better care, perhaps less water or more sunlight, the plant could go back to being healthy. But once the plant crosses over into disease, the problem may be less reversible. It may need a specific treatment, like a fungicide, for example, or it might even die. Now, in this context, the word salutogenesis could describe the blue solid arrow going from the unhealthy plant in the middle to the healthy one on the left. Now, imagine that we could represent the entire metabolic network of this plant. And now, if we could superimpose how this network changed, going from the healthy in blue to the less healthy in red, it might look something like this. You can see that the red pattern has shifted over in some places. Now let's imagine doing something similar, representing the entire metabolic network of a human who might have less than an optimal diet, sitting too much, under a lot of psychological stress, like many people during the COVID pandemic year. Now, in the middle of this complex metabolic network, or metabolome, as we now call it, most of which we still don't understand, there may be some specific parameters that we can recognize as signs of trouble. For example, hemoglobin A1C, which is represented here in the black dots. If this individual's A1C level began to rise, there would be a concern that this person may be developing prediabetes and eventually diabetes. And there's currently a push to treat conditions like prediabetes early with medications to normalize the blood sugar and avoid long-term complications. One of the glucose-lowering agents that may be prescribed in this situation is metformin. And the way it lowers blood glucose is by pulling hard on some metabolic pathways, essentially overriding them. It makes the liver produce less glucose, and it also has numerous effects on glucose absorption in the gut, secretion of intestinal peptides, bile acid metabolism, and the microbiome. We don't really understand many of these effects. Some of these may be beneficial and some maybe not. But if we could visualize the entire metabolome of this patient before and after starting metformin, it may go from this to this. The hemoglobin A1C went back to the normal range, which is great. But a lot of other things have happened that have pulled the metabolic network further out of shape. And it is the metabolic distortion that causes drug side effects. We tolerate them because we focus on the measurements that we can measure, in this case, hemoglobin A1C, as well as the long-term outcomes of patients treated with these drugs. But there are often unpleasant surprises along the way, such as the recent realization that statins can increase the risk of diabetes while at the same time reducing cholesterol levels. Now, many people with a poor diet, sedentary lifestyle, and chronic stress don't just have diabetes. They also develop co-occurring conditions like hypertension, coronary artery disease, depression, and degenerative joint disease. And all these conditions get treated as though they were independent of one another, often with drugs that not only have their own side effects, but also can interact with one another metabolically. So you can imagine this network getting more and more distorted over time as more diseases and medications get added in. But imagine instead that the same individual uses self-care and non-drug interventions to manage their stress, improve their diet, and increase their physical activity. This individual, a year later, may have a similar normalization of hemoglobin A1C as occurred with the metformin, but notice that the entire network may have moved back closer to the healthy state. So, if pathogenesis is defined as the process of moving from a healthier to a less healthy state, then would salutogenesis be the same process in reverse? Or would it require some specific salutogenic or healing pathways to be engaged in order to bring the individual back towards health? We don't know, for two reasons. First, for the last 100 years, biomedicine has been almost exclusively focused on understanding and treating disease and has paid very little attention to understanding health. Second, the process of salutogenesis, or health restoration, is very complex and involves the whole person, including multiple interconnected domains, not just biological, but also behavioral, social, and environmental, as well as multiple scales from the whole biopsychosocial person to organs and systems, to tissues, cells, signaling pathways, and molecules. And we know that this kind of research on complex interconnected systems is not easy to do, as it would mean collecting vast amounts of data in multiple systems over time. And this gets particularly challenging when measuring the effects of multiple interventions on many interconnected social, psychological, and physiological systems. Measuring large numbers of outcomes causes statistical challenges in dealing with multiple comparisons and are often labeled fishing expeditions. And one of the reasons that fishing expeditions are not often successful is that we are literally fishing in the dark with few guiding posts other than our prior data and intuition to decide what hypothesis to test. But computing methods using artificial intelligence can be trained to recognize patterns, and even better, to recognize changes in patterns over time, even when these are very complex. And this can be tremendously helpful to explore complex phenomena. For example, imagine that one could measure not only an entire metabolic network, but also microbiome, immune, cardiovascular, psychological, social, and environmental measures in many individuals at multiple time points over the course of, say, a year. This could be done simply observationally or in response to some kind of intervention. And that over the course of that year, some of these individuals would be getting healthier, while others may not change or get less healthy. And just like the hemoglobin A1C example we looked at earlier, there are some other measurements that we know are associated with a healthier versus less healthy state. C-reactive protein is another example, but this could also include patient-reported outcomes. In yesterday's chat on salutogenesis, there was a discussion of measures of emotional and physical well-being that could be used as well. And these parameters could be used to train the artificial intelligence tool to recognize whether the arrow is pointing to the right or to the left in a given individual. Once it can do this, then AI can start looking at the whole network and extract patterns associated with salutogenesis. So the grand challenge that Lanay will be telling us about in the next presentation would be to use artificial intelligence to develop models that explain how biopsychosocial networks change over time as an individual moves from a less healthy to a healthier state, with the long-term goal of eventually using these models to test salutogenic effects of non-drug interventions. The initiative that Dr. Lanay Mudd will be telling us more about is the first step of this process, and it aims at generating hypotheses-agnostic longitudinal data sets that are AI-ready to address grand challenges such as salutogenesis. I will now turn it over to Lanay to tell us more about the exciting trans-NIH funding opportunity called Bridge to AI.
Thank you, Helene. That was a wonderful introduction to salutogenesis, as well as the potential of using artificial intelligence to examine salutogenesis. So I'm going to share my screen now, and hopefully you can all see my slides. So I'm going to be talking more about the new NIH Common Fund's Bridge to Artificial Intelligence program. As Helene mentioned, NCCIH has been co-leading the development of this program along with partners at the National Library of Medicine, the National Institute of Biomedical Imaging and Bioengineering, the National Human Genome Research Institute, and the National Eye Institute. And our working group includes partners from several other institutes and centers across the NIH, as well as other federal agencies. So today I want to start a little bit more broadly with what is artificial intelligence and talk a little bit more about how it can be useful for biomedical research, and then provide more details about the Bridge to AI program and how to get involved. So what is artificial intelligence? Well, this is really the broad idea of machines being able to perform tasks that normally require human intelligence. And you may have heard the term machine learning, which is a particular form of artificial intelligence that provides machines like computers the ability to automatically learn and improve from experience without being explicitly programmed. And this can lead to many different types of applications, such as you see here on the screen, which are already in use, including more narrow AI, which have narrow goals in mind, such as facial recognition tools, improved accuracy of interpretation of pathology slides, or classification of skin cancer by images. And now we're moving into broader AI, which can help us to remove biases that may get worked in as humans program machine learning, as well as help us to learn from smaller data sets and utilize new infrastructure for AI. We are still a rather long ways off from general AI, which is the concept that a machine can learn and comprehend any task or concept that a human can, such as R2-D2 in Star Wars. Now, as our ability to do artificial intelligence is improving, as Helene mentioned, we also currently in biomedical and behavioral research have the ability to collect vast amounts of data across many spatio-temporal scales, from genetics to tissue structure and function, to the whole person, to the person in society and in their environment and populations as a whole. And these measures come across different scales from nanoseconds to days, months, years, and even lifetimes. So we're really at a very opportune moment in time where we're experiencing a revolution in data generation so we can collect more data than ever before. And we're also experiencing a revolution in data analysis techniques with machine learning and other forms of artificial intelligence that can detect patterns in complex data sets and make connections and predictions beyond human intuition. So we're really ready to build a bridge across these different fields. And that's what the Bridge to AI program aims to do, to come up with a new AI, ML, biomedical field, where the biomedical experiments can be better designed for using these different techniques, and the techniques themselves can be refined for better use in biomedical experiments. Now, one of the challenges with utilizing kind of business as usual science for these approaches is that typically we start with a hypothesis that really drives all of our decisions. So that research question or hypothesis drives our decisions about the study design we choose, what data we choose to collect, how we analyze that data, and what results get reported. And really, one of the advantages with AI and ML techniques lies in being hypothesis agnostic, and instead of being hypothesis driven, being data driven, and allowing the data to determine the patterns and results. And so in order to use these techniques, we need to be sure that we're collecting AI, ML friendly data, which means that the data come with metadata that show very clear provenance of how the data are collected, making sure that the data are very well described and accessible, typically from large data sets that are multimodal and contain perturbations over time. And the data set itself is actively learning and changing over time as well. If we can do this, there are many different opportunities for AI, ML, biomedical expertise. So in terms of biomedical science, we can use these techniques to detect patterns and mechanisms, as Helene was discussing with salutogenesis. In clinical care, this is already taking place to some degree. So take, for example, this image of a retinal scan. You or I looking at this image of an eye could not determine the sex of the individual it came from, but machine learning actually can, and can accurately predict whether this is a male eye or a female eye. And beyond that, by just taking this image that are routinely collected as part of clinical care, it can actually determine risk for other disease, such as heart disease. Now, another advantage of AI and ML in biomedical research would be to incorporate social understandings of health into these models as well. So we could incorporate measures on organizational practices of healthcare and diverse cultural approaches to health into the models themselves. And if we do this right and in an ethical way, thinking about the ethics of data use and data reuse and data sharing, we can actually use AI to detect and resolve data bias issues that might creep in and make sure that these techniques are used to improve lives of all people. So the NIH has been interested in this area for a while. In 2018, we held a workshop on harnessing artificial intelligence and machine learning to advance biomedical research, which led to, in 2019, a working group on artificial intelligence of the advisory committee to the NIH director. And this group really examined how can we start to bring these different fields together. They came up with 8 recommendations to the NIH director, which really fell into 3 different buckets. First, they said we need to focus on the data and focus on generating new data that is AI ML friendly. Secondly, they said we need to make sure to instantiate ethics across this data collection process and make sure that we're thinking about ethical principles in artificial intelligence and machine learning. And thirdly, to focus on the people, bringing together, attracting, training, and convening experts across several different fields. So in order to realize all of these different recommendations, who needs to come together? Well, we know that this is going to be a multidisciplinary effort requiring expertise in biomedical and behavioral science, as well as clinicians, ethicists, philosophers, individuals with expertise in team science, as well as data science, the AI ML expertise, mathematicians, bioinformaticists, engineers, the list can go on. So this is what Bridge to AI really hopes to do. And our goal is to focus on generating new flagship data sets as well as best practices for the collection and preparation of AI ML friendly data to address biomedical and behavioral research grand challenges. As we collect these data sets, we plan to standardize data attributes and develop automated tools for collecting this type of data, as well as create cross-training materials and workforce development opportunities, and finally, to disseminate these products and best practices to the stakeholder communities. As Helene mentioned, these data sets are going to be focused on different grand challenges in biomedical and behavioral science that require integrating all types of data to predict health outcomes, such as the salutogenesis concept that Helene talked about. Now, the Bridge to AI program is going to be structured to provide funding for data generation projects, as well as an integration, dissemination, and evaluation center. We have recently posted notices of intent to publish that provide more details about each of these funding opportunities, and I invite you to go to those notices to read more. Briefly, we plan to fund several different data generation projects, each of which is going to be centered around a different grand challenge idea. So they'll be collecting different types of data. And so they'll require expertise in the data acquisition, but we are also requiring that each of these data generation projects also include expertise in team science to help all of these different fields work together, ethics to understand better the ethical principles of AI and ML ready data, data standards and data tools, as well as expertise and skills in workforce development. Now, the Bridge Center is going to work to integrate the expertise across all of these different data generation projects and disseminate best practices in all of these areas. So as Helene mentioned, one of the data generation projects could be focused on understanding salutogenesis and include hypothesis agnostic observational data generation across all of these different spatiotemporal scales. So if I have piqued your interest, I really invite you to visit our website, commonfund.nih.gov/bridge-to-AI, so that you can read more about the notices that we've published that describe the funding opportunities in more detail, and also sign up for our listserv so that you'll be the first to know of any new updates in the program. We recognize that this type of program is going to require teams to come together with experts from different fields that may not know each other yet. And so in order to help to build these different teams, the NIH is actually going to hold different teaming activities this summer to help these different fields meet each other. So if you're interested in participating in these teaming activities and pulling together a team, to submit an application with, we encourage you to look to complete an interest statement this May. This is going to be a fast-moving program with applications due later this summer in August. And certainly you can also reach out to program staff at this email address for additional questions. So in the end, we hope that the Bridge to AI program will help to produce rubrics that allow evaluation of data sets for AI ML readiness, tools to accelerate the creation of this type of data, and a group of AI ML ready data sets that are ready to be used. And additionally, definitely a transdisciplinary AI ML biomedical community. So with that, I will end my talk and stop sharing my slides, and we're happy to address your questions.
Wow, that was amazing. I have lots of questions myself. I'll ask one and then I will open it up to folks who put them in the chat. So one of the challenges with collaboration is that people have their own views. And I know in working with some genomicists, it took a while, it took like 2 years to kind of speak the same language. Do you envision that this summer project will be the start of this multidisciplinary kind of best practices and kind of bring the best of all worlds together? Or do you anticipate it'll be a one-shot only?
Yeah, that's a really great question, Jeff. And we recognize the challenge of you know, in particular, not speaking the same language across all of these different areas of expertise. We're hoping that this summer, the teaming activities that we have planned will help to start that process. But certainly it's going to be an ongoing process. And that's one of the reasons that we particularly wanted to include individuals that have expertise in team science, that know some of these strategies for pulling people together from disparate fields and creating a shared language and creating trust across these different experts. And so I think that that expertise is going to be key to building successful teams that that can come together for this program.
Thank you. I should have started this saying, what a great presentation by all of you, and just it's so exciting to know that NCCIH is really at the forefront of thinking outside the boxes and think outside our own silos. So I want to, Dr. Langevin, I really appreciate your leadership. Dr. Mudd and Dr. Edwards, you guys are really bringing together the best of all groups, so kudos to you. One question was, the collection of this data would require access to specialized technology and facilities to gather biological, psychological, and behavioral measures. The question is, how do you ensure diversity, equity, and inclusion in this type of research, particularly in the populations that have mistrust in the health system? Not an easy question, but I'm sure you're up for it. Thank you.
Absolutely. This is a great question, and it's actually one of the primary focuses of this program is to have a very concentrated effort to include diversity, equity, and inclusion across the program. We are working hard to reach out to several different communities to get involved in the program, and that includes diverse communities, including outreach to HBCUs and others, to ensure that that voice is heard from the get-go, from the very moment of planning data collection, so that we can make sure to avoid some of the biases that may have been present in previous artificial intelligence programs. Helene, do you want to add anything to that?
Sure. I could add that this diversity, we very much hope, will include clinicians and clinician scientists so that they can lend their voice to really shaping the questions that will be asked with these artificial intelligence projects. So we really want all comers, and we're going to be reaching out. And this is one of the wonderful opportunities, like, for example, just this forum that we are able to discuss it at ICIMH. Very, very important to us to disseminate the word. So please, all of you who are listening today, help us disseminate this information to anybody that you feel may be interested.
I'm going to jump in with my own question again, so I'm not. Oh, Emmeline, please.
Emmeline
please.
to make a comment.
I was trying to say that this session is being recorded, And we anticipate that this will be disseminated widely. So if you didn't have a chance to participate, the information is going to be available to you. But we really wanted to make sure that the complementary and integrative health community was aware of this wonderful opportunity to include the kind of data that we're interested in into Bridge to AI.
That's great. Thank you, Emmeline. I had a question. We're always worried that the patient voice is lost. And I'm sure in this process that it's genomics, metabolomics, microbiome assays, but the patient voice and patient-reported outcomes are also critically important. Do you envision that being part of the mix and having the patient be involved in their own words, as well as even some numbers, pain scores and things like that?
Yes, absolutely. Each of the data generation projects is going to be focused in different, grand challenge areas. And so it might have very different types of data associated with that grand challenge. But the goal is that each of them will, have multi-scale data and multi-type data and incorporate, not only the biological measures, physiological measures, but also psychological, social, patient-reported outcomes, et cetera. And we also are, very interested in getting stakeholder and community involvement. And so, having patient advocacy groups and things like this as part of the effort is important to us. One of the things that we're hoping to do is hold kind of data jamborees every year that stakeholder communities, individuals who aren't funded through the program have the opportunity to interact with the grantees and provide advice and, and insights into what's happening along the way as well.
That's brilliant. The transparency will be really important to increase trust and just even ideas coming from patients. The next question is, are we assuming aberrant, quote unquote, network patterns are the same for everyone, or could there be individual variations? And if so, what are the implications for generalizing pattern recognition versus personalizing on a person-by-person basis? It's a lot in there, so just take it as you like.
Well, I can say something that I think it'd be very surprising if it was the same thing for everyone, right? And I think this is one of the things that we can discover using these tools is what are the variations across people? Can you identify some clusters of individuals who may be more likely to restore their health under one circumstance versus another? And so I think the range of questions that we can ask, once we get the methods down, once we can collect these data in ways that are correct and fully functional, the sky's the limit. I think you could really start to identify what each an individual person's pattern, but also common patterns across groups of individuals. So yes, I think that individual differences will be very important here.
And even just feeding back, as people are progressing, it's not working after X number of weeks of a particular intervention, try something else versus waiting, 2 years or something. So, okay. What are the clinical questions, what clinical questions will best or first be addressed by Bridge to AI? Is there a research agenda or certain priorities, or is that still too early for this?
Yeah, that's a great question. I will say in our notice of intent to publish, we have listed several different potential grand challenge ideas, including the salutogenesis concept, which Helene described, but also different things like functional genomics or digital twins, things like this that also have, the need for collection of broad types of data in order to address. However, these are all just kind of examples of potential grand challenge ideas, and we definitely have left it open for the community to also come in with their own ideas as well, and describe those in addition to those that are laid out as examples.
Very nice.
And Helene, do you want to add anything to that, or Emmeline?
Yeah, Emmeline, and then I can make a comment as well.
I also wanted to remind everyone that, as Dr. Mudd explained, this initial project really would be data generating project, and that later on, we could actually mine those data sets for hypothesis driven a project. So while we anticipate that we'll be able to get, address a number of research gaps, I just want to remind everyone that this first step is going to be data generating that will be AI ready.
That's right. Yes, and we're highlighting the salutogenesis concept here because we think it's particularly well suited to this approach, and also because it's really difficult to do it any other way. It is likely to be so complex that other approaches are likely to fall short. And so we think that this could be transformative for the field of integrative health to invest some effort into this area. So this is one of the reasons why we were so excited to find out about the Bridge to AI initiative, and that NCCIH became involved in the initiative in a very active way.
Again, I tip my hat to you all, because certainly this is a very forward-thinking area, and oftentimes it really takes that kind of long-term view to really make a difference. Next question is, as data is often obtained, excuse me, my phone changed, at the level of individual, how is the neighborhood and or community level data being thought of?
So I can start with this. There are many different approaches that could be used. I mean, there are geospatial imaging type of information that could be used, things just from zip codes that we have, standard relationships between zip codes and different health outcomes. This can be scraped from internet data and from other sources as well. So from existing data streams, we can collect some of that. Some of it will be patient reported outcomes as well. So there are many different options, and we really will leave it to the applicants to, kind of come in with their suggestions for how they want to capture that type of data and what it might be able to represent. Any other ideas there, Ellen or Emmeline?
Well, I think the fact that we really want to, when we're talking about whole person in NCCIH's strategic plan, we really focus on the whole person, but we also include the social and environmental aspects of the whole person, how a person interacts with their environment. And it's not just the person, the family, the community. So I think that this is something where we're not drawing a box around this. There's definitely a great need to relate data on individuals to what's going on in the environment around them, being the social environment and the physical environment.
Emmeline, anything that you want to add? I didn't know if you were going to.
No, I'm good. I think we covered that.
Okay. I mean, it seems as though we're at this juncture with all the different monitoring tools that we can have to measure blood pressure and other things from afar. We're all using Zoom technology to use to meet patients where they are. And again, not to bring up the downsides, but are there any risks you guys see to this process? Or maybe none, but just it seems so positive in the salutogenesis opportunities. Are any worries about this endeavor at all?
I think that's a really good point, Jeff. And that's actually one of the reasons that within the data generation projects, we're requiring this core of expertise in ethics. And so we want to include individuals with ethical, legal, and social implications expertise to really grapple with, what are some of the unique aspects of informed consent, for example, for these types of techniques where the data is going to be used and reused for different questions. How can we maybe incorporate broad consent or other things like this, or what types of data need consent? And some types of data don't. And so we really are encouraging that ethics module within each data generation project to think through what are the unique ethical challenges for the data generation that we are proposing to do. What are approaches we might take to address those ethical challenges? And then the Bridge Center is really going to be trying to integrate those lessons learned across the different data generation projects and come up with best practices overall for thinking about how to ethically develop AI ML ready data.
I mean, having been involved in a collaboration, BraveNet, which is the Integrative Medicine Practice-Based Research Network, collaboration is tricky. So this is not a small task. So I know that this team's up for it, but and again, the jamborees and all the approaches are really important to consider to motivate that. If you had one hope, if there was one small thing that you would love to see in the next 2 years, maybe each of you say, like, what would be one step to feel like you're on the right path with this kind of endeavor? We'll start with you, Helene. If you had one small thought that would make me feel like I was on the right track.
My hope would be that the complementary and integrative health research community would respond to this challenge and submit applications. I think this is really, and participate. As Lanay mentioned, this is going to be fast moving. This is a common fund initiative. So it first of all involves the entire NIH, and it is funded by the Common Fund, which is a separate set of funds specifically for this. And it is really going to move rather quickly. So it's going to be challenging, but well worth it. And so we hope that people will just really take this very seriously and go to the website that Lanay pointed out, look out the instructions and submit a letter of intent in May, because this is really important.
Emmeline?
I will also add that I think that the community inherently, because of the involvement in integrative health, is poised to actually take advantage of that opportunity. And as Helene said, even though it's a pretty fast-moving program, we really hope that they will rise up to the challenge. So that would be my my wish and goal to make sure that this happens.
Lanay?
Yeah, I'll just add on to both of those. My real wish for this is that we really do create a transdisciplinary AI, ML, biomedical community that incorporates individuals with the complementary integrative health expertise. I know that we're starting kind of as bringing together people with individual expertise. So it's kind of multidisciplinary to start with, but I really hope that they, start to talk to one another and learn from one another and become this transdisciplinary community. And I do want to just emphasize, you don't need to know anything about artificial intelligence in order to participate in this. And in fact, it's totally fine if you don't have existing knowledge about artificial intelligence or machine learning or any of those techniques, but you do have really great clinical expertise or, great behavioral science expertise. We really are looking forward to, pulling individuals from those different fields together so that they can learn from one another.
And be a team player. I mean, don't come at this as you're the prima donna. Be a team player. Yeah. Team science is where it's at. So I'm so thrilled that you allowed me to moderate this, and I got to most questions. I will say the chat has been amazing. People have been very supportive of NCCIH taking this leadership role. And so I really want to give you that feedback, that both the Salutogenesis side as well as the innovation. So again, we really look to you as partners from the field and really appreciate all that you're doing. So I know it's challenging and you've got tough day jobs, but thank you for taking the time to be here. And we so appreciate you giving us the heads up, because we may not have heard this otherwise. So we really appreciate this opportunity. I think we'll leave it there, but thank you all and have a great rest of your day.
Thank you.
Thank you, ICIMA.
Thank you.
Bye.
Bye-bye.
Bye.